Hello friends, welcome to my channel Tech Explorer. I hope you all are doing well. In today's session, we are going to learn Numpy in a very simple and easy way. This video is prepared for those who want to learn about the basics and various functions of Numpy. After watching this video, you will find yourself at a moderate level of expertise, and you can take yourself to the higher levels of expertise by watching the second part of this tutorial. Now let's see what's the agenda for today's session. We are going to learn what is Numpy. We are going to see how we can install Numpy. Then what are multidimensional array and lists. How we can create and access the Numpy n-dimensional array. And the various operations you can perform on the Numpy arrays. And Numpy arrays versus list. Since understanding Numpy is the starting point of data pre-processing and later on implementing the ML algorithms, and if you're about to learn machine learning in the near future or has just begun and you want to get a more hands-on experience in learning Numpy for ML, then this video is definitely for you. So what we are waiting for? Let's begin. So let's see what is Numpy. Numpy stands for Numerical Python. It was created in 2005 by Travis Oliphant. It is the fundamental and most powerful Python library to work with data. It handles large datasets efficiently and effectively. So it's the most useful scientific library that provides support for large n-dimensional arrays. Numpy has large collection of high-level mathematical functions to operate on the n-dimensional arrays. And it has functions for working in linear algebra, Fourier transform, and matrices. Now we come to installation of Numpy. So if you have Python and pip already installed in your system, then simply type the below command for installation, that is pip install Numpy. Although Numpy is a Python library, but it is partially written in Python. But most of the parts that require fast computation, they are written in C or C++. So, if you are a data scientist or an aspiring data science professional, you need to have a solid grasp on Numpy and how it works in Python. And now that you have set up your environment, it's time for the real work. Now let's begin by checking the version of Numpy that is installed in our system. For that, we have to import Numpy as NP. NP is the alternate name that is used to refer Numpy. Alternate name can be given in Python by using keyword as while importing. Now you can refer Numpy as NP anywhere in the code. Generally, Numpy is referred by NP. The version string is stored under the version attribute. Now let's see what are multidimensional or ND arrays. So multidimensional arrays can be considered as powerful data structures or technique of defining and storing the data on a format with more than 2 dimensions. You can consider it as a table of elements, usually numbers, all of the same type, indexed by a tuple of non-negative integers. In Numpy, dimensions are also called axes, so we will come to it later on. In Python, multidimensional arrays can be implemented by fitting in a list function inside another list function, which is basically a nesting of operation for the list function. So let's see what's a list. Lists are a collection of similar types of values that are separated by commas, and they can be used to represent data in this format. Lists can have data such as integer, float, string, etc. and can be modified as well after creation. The indexing in list is pretty straightforward, with index starting from 0 and stretches until the whole length of the list minus 1. So when list has other list as its element, it forms a multidimensional list or array. You can see the format below. So this list is having 3 lists as its element. Let's see what are the various types of ND arrays and how we can create them. So the very first is the 0D arrays. So they are also called scalars. They are the elements in an array. Each value in an array is a 0D array. So for that, you have to import Numpy as NP and simply call the Numpy array function and pass a value. Here, for example, it's 42. So this is going to create a 0D array for you. Now we come to 1D arrays. So a 1D array has 0D arrays as its elements. So for creating a 1D array, you have to import numpy as np and then call np.array function and simply pass a list of values in it. It is going to create a one-dimensional array for you. If we come to 2D arrays, an array that has 1D arrays as its elements is called a 2D array. It's often used to represent matrix or second-order tensors. So we have to pass a collection of 1D arrays to the array function of numpy to create 2D arrays. Then we come to 3D arrays. In 3D arrays, we have collection of 2D arrays or matrices. They are the elements. You have to pass a collection of 2D arrays to the numpy array function to create the 3D arrays. Now let's see the numpy operations. So first, let's check the dimension of our numpy arrays. So a dimension in array, you can consider it as one level of array depth in nested arrays. And nested arrays are those which have arrays as the elements. So numpy provides an endim attribute that is going to return an integer number and it will tell you the dimension of the array. So you can check it out yourself for the various types of nd arrays in numpy. So first of all, let's import numpy as np and then create a 0D array by calling a function np.array and passing a value. Here it's 42 for example, and then print the dimension of that array by calling a.endim, that is the attribute which numpy provides to check the dimension. And you're going to simply get 0 because it's a 0D array. Then you create a one-dimensional array by passing a list of values and then print the dimension of that array. You're going to get 1. Similarly, for 2D arrays, when you print the dimension, you're going to get 2, and for 3D arrays, you're going to get the dimension as 3. You can run this code for yourself and check it. Now let's see the other numpy array operations. So first, let's see how to check the data type of your numpy array elements. You import numpy as np, create a numpy array, and then call the dtype attribute. Here in this example, you are going to get int64 because you can see the various elements are of integer type. Then how to check the total number of elements in your numpy array? Simply create a numpy array and then call the a.size attribute. This is going to give 3 because we are having 3 elements in this array. Then we come to checking the size of each element in the numpy array. We create a numpy array and then to check the size of that numpy array, we call the attribute item size. Item size gives you the size of each element. Here, as they are integers, we are getting 8 bits as the answer. Now let's see the numpy array indexing, how we can access a 1D array. So very first, we create a one-dimensional array by passing a list of values. To access any element of 1D array, simply pass the array name and within square brackets, the item number. Always remember, the indexing starts from 0. So here in this example, we have passed the array name and within square brackets, we have passed 1. So this is going to give you the second element of the array as indexing starts from 0. And you're going to get 2 as the value. So now accessing a 2D array. We create a 2-dimensional array. To access an element of 2-dimensional array, you pass the array name and pass 2 values within the square bracket. The first value will tell you which 1D array to access, and the second value will tell you which element within that 1D array you have to access. So here in this example, array 0, 1 means the 0th 1D array and 1 means the second element in the 0th 1D array. That is, you're going to get 2 as the value. Then how to access the 3D arrays? You create a 3-dimensional array, and to access any element of the 3D array, you have to pass the array name and 3 values. The first value will tell you which 2D array you have to access. Second value will tell you which 1D array within that 2D array you have to access, and the third final value will tell you which value within that 1D array you have to access. So here in this example, array 0, 1, 2, you have to access the very first 2D array, and 1 means the second 1D array within the first 2D array and the third element in that 1D array. So this is your 6. Now let's see the NumPy array slicing examples with 1D array. Here we have created a 1D array. Now to get a selected range of values, we pass the name of the array, and within square brackets we have given two values separated by colon. The first is the starting index and the second is the end index. Here end index is not considered, that is, you are going to get the values whose index number starts from 1 and ends till 4. So here for this example, you are going to get values 2, 3, 4 and 5. Second example, we are giving only the start index and not the end index. So we are going to get the elements whose index number starts from 4 till the end of the array. So here you are going to get 5, 6 and 7th element. Now the third example, we are not giving the starting index, we are giving only the end index. So we are going to get all the elements whose index number starts from 0 till index number 3. That is, you are going to get the elements 1, 2, 3 and 4. Now the final example, when we are passing negative values as index number. So we know that the array elements, the index number starts from 0 and the last element has an index number, that is total length of the array minus 1. So when negative index number is given, that is minus 1, it always indicates the last element. Minus 2 means the second last and minus 3 means the third last. So when minus 3 is given as the starting index and minus 1 is given as the last index, you are going to get two elements, 5 and 6. Now let's see the NumPy array slicing examples with 2D array. So here we have created a 2D array. In this example, we have passed the array name and we have passed two values separated by comma within the square bracket. The first value tells us which 1D array to access and the second value tells us the elements within that 1D array. So the first value, that is 1 here in this example, means the second 1D array, and 1:4 means all the elements whose index starts from 1 till index number 3. So here you are going to get the values 7, 8 and 9. In the second example, we have given 0:2 as the first value and 2 as the second value. So 0:2 means all the 1D array whose index starts from 0 till index number 1, and the second element, which is 2, means the third elements of all the 1D arrays. That is, in the first 1D array, the third element is 3, and in the second 1D array, the third element is 8. In the third example, we have given ranges in both the values. So the first value 0:2 means all the 1D arrays whose index starts from 0 to 1, and the second value, that is 1:4, means all the elements in both the 1D arrays whose index number starts from 1 till index number 3. So you're going to get the elements of the first 1D array, that is 2, 3, 4, and the second 1D array, that is 7, 8 and 9. Now let's see what is shaping and reshaping of NumPy arrays. The shape function returns a tuple of integers that shows the number of elements in each dimension of the ND array. So here in this example, we have created a two-dimensional array, and when we call the shape function, it returns us two values, that is 2, 4. As here in this example, there are two 1D arrays, and in each 1D array, there are 4 elements. Then we come to reshaping of the NumPy array. So reshaping means changing the shape of an array. The shape of an array is the number of elements in each dimension. So by reshaping, we can add or remove dimensions or change the number of elements in each dimension. So here in this example of the 2D array, the shape is given by 2, 3, as we have 2 rows and 3 elements in each row, that is 3 columns. Total size is 6 total 6 number of elements, and the dimension is 2. So when we call reshape and pass the array name and two values, that is 3, 2, that means we want to create an array with 3 rows and 2 columns. Now let's see how to create NumPy arrays of your choice. So the very first is to create an array of ones. For that we call np.ones. Ones is a function of NumPy which is provided to create array of a choice, and that will be filled with all ones. So here in this example, when we call np.ones and we pass two values 3, 4, it will create an array with 3 rows and 4 columns all filled with ones. Then how to create array of zeros? We call the zeros function. Here it will create a 3-dimensional array filled with zeros. Data type is integer. The third example is to create an array with random values. Here we have called the function random.random and we have passed 2 values. So here it is going to create an array with 2 rows and 2 columns with any random values. Now let's see how to create a full array. We call the full function and we have passed the values 2, 2 and 7. This 2, 2 will create a 2-dimensional arrays with 2 1D arrays and 2 elements in each 1D array, and that will be filled with value 7. Then we create an array of evenly spaced values. For that we call the function linspace. This is going to create an array of 9 values which are equally spaced from 0 to 2. Now let's see why I should use a NumPy array when I have already a list. So NumPy arrays uses less memory than lists. The NumPy ND arrays are more faster than lists, and NumPy arrays are more convenient than lists. So check for yourself which one occupies more memory. Just run the below Python code. So firstly, import NumPy as np, import time, import sys. Then start checking the space occupied by the list. For that, create a list by calling the range function. So in this range function is going to create a list with 1000 elements starting from 0 to 999. Then get the length of the size of the list by calling the sys.getSize of function and passing any element in that and then multiplying by the total length of the list. This is going to give you the space occupied by the list. Then check the space for NumPy array. For that, create a NumPy array first by calling the aRange function. It is similar to range function. This is going to create an ND array with 1000 elements. Then simply call d.size. This is going to give the total number of elements multiplied by the size occupied by each element, which is given by d.itemSize. Now let's check for the second example, which one is more faster. We will take 2 lists and 2 NumPy arrays, and then we will add the elements of the list and the elements of the NumPy array, and we'll see which one is faster. So we import NumPy as np, we import time, we import sys, we have taken size value, then we have created 2 lists L1 and L2 by calling the function range and passing size. Then we have created 2 NumPy arrays A1 and A2 by calling the function aRange and passing the size. Then we have taken the starting time variable, that is start equal to time.time. To add to list, add the elements of the list. We can't directly add it L1 plus L2 because it will concatenate the 2 lists. So to add the elements in the list, we have to run a for loop. Then after adding the elements of the list, we have taken the time again and printed the time, how much time it has taken. We have multiplied it with 1000 because to get the value in milliseconds. Then again we have taken a start variable to check the time, and we have taken the addition result of two ND arrays, and then we have printed the time again. So run these 2 codes and check for yourself which one is faster, the NumPy array or the list. So you will see that the NumPy arrays, they are more faster, they occupy less size, and they are more convenient than the list. So in the next part of this tutorial, we will move on to the powerhouse tools that are built on top of the foundational building blocks you saw in this video. We will be moving towards more advanced level of operations in Numpy that will take you to the higher level of expertise. If you have any queries, do let me know in the comment section below. If you like this video and found worthy, do subscribe my channel. Thank you.